Welcome once again. Yeah, we are going to deal with combinatorics. Combinatorics. Let me try to hold on, please. Let me so that I can combinatorics. Let me run a bit, please. Let me open a file. Let me say combinatorics. Let me say. Let me not call it combinatorics. Let me say data science. TFT as a text file. Yes. So we're going to be dealing with combinatorics, combinatorics. So my essence for using an ID independent and integrated development environment is for you to be able for me to be able to write something while I'm teaching. So like I said ab initio, we're going to be dealing with combinatorics and its relationship or application to probability. So please ignore this. It's not for you. It's for Python programmers. So I'm just trying to use my intention for creating this txt file is for me to be able to write while I give instructions. You understand? For better understanding. So ignore these files there. These Python files. There. It's not for you. So for beginners like us, we will refer combinatorics as something that deals with the combination of objects from a specific finite. Let me write it out. Uh, say combinatorics can be referred to. Okay, this can be referred to uh, as let's say something that deals. Let's say something uh, deals. It's something that can be referred to as something that deals with combinations of objects. Let's say with let me collapse this tray here. So that's for me. Yes. So this can be referred to as something that deals with the combinations of objects. Let's say okay, so with deals with combination of objects, combination combination of objects. So that deals with combination of objects from a specific from a specific okay I mean it's from a specific say a specific finite set. Of course, finite set, by finite set we mean a set that is not infinite. So we shouldn't stress on that. So in dealing with combinatorics we have to understand certain restrictions. You know, these are repetitions. Let me write them out. These are the restrictions uh to always understand. Let me just say repetitions, we have order, we have then other criterions. So we're also going to explore what forms of combinatorics we have. For example, when talking about combinatorics, we have types of combinatorics. Let me say types. We have permutations, permutations. We have say iterations, variations, we have combinations. We have combinations. Have combinations. So we will use each of these to determine number of favorable outcomes or number of all elements in a sample space. So the first thing we are going to start with is permutations. What is permutations? Okay, let me say permutation is the it is the number of different possible ways we can arrange a set of elements. So the element you are referring to here can either be digits. It can be digits. When we're talking about the element you are referring to, it can be let's say digit. It can be say letters. It can be say. Excuse me. Let me shut the window here. Excuse me. So it can be letters. It can be what else? It can be object or even humans. It can be objects. It can be objects or even humans. It can be objects or even what humans. It can be anything. You understand? These are the permutations we are referring to when dealing with what permutations. So, okay, let me give a real life scenario. Let me give an example. I think we from that example we'll be talking, or will be I'll, I think it will make a lot of sense if I use an example to explain what permutations are. Let's imagine we needed to arrange three musicians. Let's say we needed to arrange three musicians or three music contestants. So let's say we want to decide to award three music stars and arrange them according to their medals. We can have in these medals, let's say we have gold, we have silver, we have bronze. And of course, we want to award three music stars using this award. So let's say we have Davido. Let's say we have Davido. Let me see, Davido. Let's say we have Whiskey, example, and let's say we have Burna Boy. Let's say we have these three stars. So let's assume Davido is awarded gold. And of course, we are deciding to arrange them according to their award. The gold winner stays in the middle, while the the silver winner will stay by the right hand side of the gold winner, and of course the bronze winner will stay by the left hand side of the what uh gold winner. So let's say Davido won the award, of course gold, and of course it's going to stay in the middle. So let's assume we decide to put bronze by the left hand side of Davido and silver by the right hand side of Davido. So since Davido occupies the middle spot, I hope I'm making sense. Then we are left with what? Whiskey and Burna Boy to either move to any position, either position according to their medals. So if you decide that Whiskey stays in the middle, let's assume Davido didn't win. Let's assume Whiskey won, and Whiskey decides to stay in the middle. So we are as well as what we are faced. We are also faced with the challenge of arranging either Davido or Burna Boy. So from this analysis, you agree with me that there are six possible ways, or say six possible ways. From this analysis now we can say uh six possible ways, um or say unique ways the three stars can be split, or the three stars can split the medals. When we arrange Davido in the middle, we are left with the choice of having either Whiskey or Burna Boy having the silver and bronze. If you have Whiskey in the middle, that means the middle person is the gold winner. So we have either Davido or Burna Boy. The arrangement, we have six possible ways of what arranging them. So Therefore, we call these six ways permutations. Going forward, I'm going to show you how to compute permutations of finite numbers of any size. You understand? By finite number, we mean numbers with limit. When in mathematics or statistics, when they say finite numbers, it means numbers that have an end, a number that a particular or numbers that have end. You understand? So number that have an end. If it is infinite, it is what? Numbers without what? Ending. You understand? Uh, we call such numbers googolplex. It has no ending. You understand? So because we are dealing with finite numbers, so we're going to be computing permutation of finite numbers of what? Any size. So to get the formula for permutations, I'm going to use of course, this example of musicians. So let's assume we don't know who the winner is. Let's assume, um you know prior to what we said, that Davido won, Whiskey, with silver, Burna Boy, bronze, or whatever ways we decide. Let's now assume that we don't know the winner, of course. And of course, and remember, the award decides the position they are going to be arranged in. So if Davido wins, Davido stays in the middle. If Whiskey comes the silver holder, then or silver awardee, then Whiskey stays by the right hand side of Davido. And if Burna Boy becomes the bronze, Burna Boy stays um by the left hand side. So if Burna Boy wins the gold medal and Whiskey becomes the bronze medal, Whiskey stays. She understand? So we don't know the arrangements as far as this example is concerned. Let's assume we never put any arrangement. So and of course, like I said, the arrangement determines the position. So for not knowing, we say the gold awardee winner will be arranged. Let's say the gold, because we don't know. So the gold awardee winner will be arranged what? In n ways. Let's say n ways, because we don't know. You understand? And definitely, since the first winner, which is the gold winner, is n ways, invariably the second winner will be what? N minus 1 ways, because we don't know. So since we decide that the first winner will be n ways, the second place will be, the second person will be what? N minus what? 1 ways. So n minus what? 1 ways. And of course, the third person will be what? Say n minus what? 2 ways. N minus what? 2 ways. You understand? And the fourth person will be what? Let's assume there are many other musicians. So the fourth person we have what? N minus what? 3 ways. Then like that, up till let's see, let me write them out. Let me write it out. Excuse me. Um Third person will be what? N minus, sorry, the fourth person will be what? N minus 3 ways, up till dot dot dot, up till what? 1. You understand? In mathematics, if you have dot dot dot, it means it continues up till, the last number after dot is up till that particular position or number. So from this analogy, we can say that um, the permutation of n equals what? I think I have something that depicts it. Yeah, yes. So we can say the permutation of n equals what? N times n minus 1 times n minus 2 times up till what? X, that is times 1. So because it is that, now that the product is denoted by, because it is that, because permutation now we now equals what? The product of n minus 1 and n minus 2 up to what? 1. You understand? So multiplication means product. When you hear product, it means times. When you hear sum, it means what? Plus. So from this we are saying, of course, Pn, that is the permutation of n, equals the product of this. So this product can as well, this thing here, this whole thing here, can as well be what? Denoted by what? This sign. And this sign means what? N factorial. It means factorial. This whenever you see this exclamation mark, this single exclamation mark in statistics, it means factorial. So all of these means what? N factorial. N factorial. So uh in the next this thing, okay, we're gonna be discussing. Let me even move there. Let me not say next. Let me move there. Let's continue with factorial. Let's continue with factorial. So I don't want to cut it. I don't want to split this particular this thing. So what is factorial? Well, let's assume I don't know what factorial is. So let's go to Google and ask Google what factorial is. Let me go to google.com. Google.com. Factorial. Factorial. I told you, students, it's better to always find out things. Let's say factorial. So what is factorial? Factorial in mathematics is the what? Product of all positive integers less than or equal to a given positive integer and denoted by the integer and an exclamation point. Thus, factorial 7 is what? 7 factorial, meaning 1 times 2 times 3 times 4 times 5 times 7. Factorial 0 is defined as equals to 1. We're going to be coming to that anyways. So that is the definition of factorial that we just saw in Google. So let me say to simplify it, we can say uh, n factorial, n factorial, n factorial equals what? The product of natural numbers from n 1 to what? N. The product of what? Natural number from what? Say 1 to what? N. That is this n factorial here. This n here is here. You understand? So if invariably, if I have 7 factorial here that was used in Google as example, if I have 7 factorial here, it will now be what? The product of natural number from 1 to what? 7. If I have 8 factorial here, it will be the product of natural numbers from 1 to 8. You understand? So by natural number, what does natural numbers mean? Natural numbers are what? Whole integer, positive integer. That is, by natural number we mean real positive integers. That is numbers that are positive and without what? A decimal point. So by the definition, natural numbers are not negative. No negative number is in natural numbers. It means real numbers that are what? Either that are positive and they are not with what? Decimal point, like 1, 2, 3, 4, 5, up to 1 trillion. As far as there is no decimal point and what? They are not negative. So those are natural numbers. So by the definition we can say n factorial is what? Say 1 times 2 times 3. This is what they are trying to tell us in Google. Apart from this definition, this is what they are trying to tell us. N factorial equals what? Um, say 1, say times 2 times 3 times 4 times 5 up till times n, up to what? Times n. Sorry, let me space it out so that it will be it will make sense. So that it will just be okay. Okay, that's that. So n factorial simply means 1 times 2 times 3 times 4 times 5 up till what? Times n. So if we have 4 factorial here, let's assume we have 4 factorial. Let's say 4 factorial. 4 factorial means 1 times 2 times 3 times 4. You understand? Times 4. That is what? 4 factorial. This arrangement is not a must that you follow this arrangement o. You can start from 4 times 3 times 2 times 1, the one we are used to in Nigeria. In Nigeria, we start with the highest number. So this is the American standard, but it is not a must that you follow it. In Nigeria, we would have started from, or we will be starting from 4 times 3 times 2 times 1. So that is, you understand. So I don't know of any other African country, but I know in Nigeria, in Ghana and stuff like that. So now let me give you the important uh let me give you the important properties of factorials. One, let me say properties of factorials. Properties of factorials. Let me use uppercase. Properties of factorials. Properties of factorial. One, one. Negative number do not have factorials. Negative numbers do not have what? I mean, don't have what? Factorials. Two, two. Always remember that zero factorials equals always remember that zero factorials equals what? 1. Always remember that. Always remember that. So another factorial is just a shortcut to factorial. Another property is just a shortcut to factorial. Say, we said n minus 1, I mean, sorry, n factorial is what? 1 times 2 times 3 times 4 times 5 up to what? N. You understand? Up to times n. So here, this one here, this thing here, we can collapse it to say, let me put it as a third property. We can collapse it to say uh, n factorial, let me use up lowercase, n factorials equals, say, um, n times, say, n minus 1 factorials. I can explain this. What I just did is just to collapse this into what? This. Is just to collapse this into this. This is very important because it might stand as one of the algorithms to compute factorials using Python. So um, just make sure you have this at the back of your head, but you need to understand how we came about this. So this is it. Look at this again. N factorial. 1 times 2 times 3 times 4 times 5. You understand? Up till what? Times n. Now, we now say n factorial. We now collapse it to be n times n minus 1. Now, let's assume um, it is we didn't use n factorial. Let's assume we use 4 factorial and use the collapsing method. So we can now say n is we represent n to be 4 here. So we can now say uh 4 times, what do we have? N minus 1. That will be what? 4 minus 1 uh factorial. So we are saying 4 factorial, sorry, 4 factorial is the same thing as what? Say 4 times 3 factorial. 4 minus 1 is what? 3 factorial. Let me put it there. We now left with what? 3 factorial. Now, 4 factorial can as well again be equals to what? 4 times, what is 3 factorial? 3 times 2 times 1. This 3 factorial here is 3 is this. You know, any factorial will be what? Multiplied down to the lowest or from the lowest. She understand to the highest. So it does, like I told you, it doesn't matter how you arrange it as far as you have the multiplication ending to 1 or starting from 1 uh to the number that was used to represent the factorial. You understand? So we have here 4 factorial, 4 times 3 times 2 times 1. Following this formula, 4 times 4 minus 1 factorial. So 4 minus 1 is what? 3 factorial. So 4 times 3 factorial. What is 3 factorial? 4 times 3 times 2 times what? 1. So the formula is accurate. So practically we can say, we can say, let's, if we have 6 factorial, we can say 5 factorial times what? 6, or say 6 times what? 5 factorial. So as the case may be. So we have also another one we should not forget is what? 2 factorials. You know, I mean, two, not 2 factorials in 2, 2, what we have been dealing with all through now is what? Single factorial. So let's say the 2, what I mean here is double factorial, not 2 as in 2. So I mean double factorial. Factorial. All we have been dealing with over time now is what? um Single factorial. So let's assume we have double factorial. let's assume we have let's assume we have factorial n and k. let's assume let's assume let's assume we have factorial what? Factorial, uh let's assume we have factorials, say n and what? And k. And of course, n is what? Say n is greater than what? K. Let's assume we have factorials n and k, and what? N equal is greater than what? K. That means n is what? Bigger than k. So invariably we have two factorials here, n and k. You understand? So invariably n factorial divided by what? K factorial is the same thing as what? Having same thing as having k plus 1 times k plus 2, say, times up till times n. This is a very important formula. So n factorial divided by what? K factorial equals this. Now let's now prove it. Let's prove this formula. Let's prove this formula. I won't give you any formula without proving it. So let's prove this formula. Let's assume uh 4 factorial is, let's assume n is 4. So we are going to be having 4 factorial. And let's assume k, because we said kn is greater than k. Let's assume k is 3. So we're gonna be having what? We're gonna be having 3 factorial. You understand? So let's now put it in raw, as we know how to solve factorial ab initio. So we're gonna be having 4 factorial will now be what? 4 times 3 times 2 times 1 divided by, what is 3 factorial? 3 times 2, sorry, excuse me, 3 times 2 times what? 1. You understand? So if we have this, we can say, to cut it. Let's assume we want to cut it. You agree with me that this one, it means what? 3 times 2 times 1 is 6. 3 times 2 times 1 is 6. So we can cut this 6 divided by what? 6, 1. So 4 times 1 is what? 4. So the answer will give us what? 4. You understand? Now let's now use this formula instead of doing it raw. Now we have we will now substitute what? This We will substitute what we have here inside here. Now let's assume, we said, they say here n divided by k will give us this. So we want to use this formula. I've done it raw so as for you to let us know the answer. So let us now use the formula that I gave to prove that the formula is right. So let's see if the formula is right or wrong. So we have what? 4 factorial divided by 3 factorial. N here is the same thing as 4 here. K here is the same thing as what? 3 here. So let's now put it there. So what will be substituting now? But by substitution, I mean what will be changing. When you hear substitute, it means change. I don't mean subtraction. So what will be changing here is what? 3. So we now have what? 3 plus 1, which is what? 4, abi, times 3 plus 2, which is what? 3 plus 1 is 4, 3 plus 2 is what? No, sorry, excuse me, I'm making a mistake, sorry, excuse me, let me see. 4 times 3 times 2 times 1, yes. So yeah, 3 times 2 times 1, yes. Mhm. Yes, which is 4. Let me see. 3 minus 1, 2, plus 2, 1. Hmm. I made a mistake here. I think this should be minus. I'll check again. Sorry, this should be minus. Excuse me. It should be minus. Okay. Okay. You know what? Let me go back and solve that. So I will come back on these in our next class so that I won't get us confused. I'm missing something here. I think um, though I what I did was to prove the formula. So after proving the formula, it gave me something. I think it's minus that it gave me, but I'll go and prove it again and come back because I don't just give formula out. I have to do the proof. Of course, the proof you don't need the proof, yeah, because it's raw mathematics. Yeah, most of you might not be coming from a mathematics background, so I don't want to scare you by showing you the proof. So I'll go back to the proof and I will deal with that. So that is that on uh factorials. So but two factorials, we're gonna be coming back to the two factorials. So our next class, what are we talking on now is variation. But don't forget, I'll come back to these two factorial so as for me not to, I won't skip it. I'll come back in our next class to these two factorial, please. And if I forget, please remind me in Telegram or on Discord. So variation, the next one we're having is what? Variation. There are two major types of variation. Let me write it. Variation. Variation. There are two major types of variation. We have variations with repetition, and we have variations with repetitions, and we have let me see, variation with repetitions and variation without repetitions. Yes. So we are going to be explaining them with examples, so that we can see how they are working in practical. So I think I should. It is not wise for me to go into variations without doing that to double factorial. So let me treat that and come back to this class so that I will treat that and I'll tell you my errors. I won't do behind the scene errors. I mean behind the scene corrections. I'll do my corrections right in front of you, and of course I will show you what happened and why the mistakes. You understand? Please pardon me for that. I'm sorry. So I'll go and check that again, solve that, and come back and give you the corrections and explain how I came about the corrections so that we can go into variations proper. I don't want to go into variations without having to deal with that. Thank you very much for this class. Appreciate your audience. So if there's anything you are still finding difficult, let me know, and you can send me a message in Discord, on Discord, or on Telegram. Thank you, and God bless.